Greetings, viewers. Topic of presentation for today is algorithmic and machine learning based solutions for EV charging. I am Farazuddin Mohammed, a graduate student at San Jose State University with my master's in software engineering. So, about electric vehicles, they are popularly known as EVs. They use an electric motor for forward motion and they require planned charging sessions using what is called as the electric vehicle charging station, also known as EVCS. They are a key solution in the fight against climate crisis. And our focus today will be to discuss challenges and solutions related to EVCS and the development of predictive models for EV charging. On the right shows a figure that will show that there are various sources of energy that contribute to a central grid, which is later going to provide energy to the charging station and which can be used by electric vehicles for charging. The environmental imperative of EVs. EVs play a vital role in combating the climate crisis as highlighted by the NIEHS. Traditional internal combustion based vehicles uh, contribute significantly to global carbon emissions, making the shift to EVs very imperative. The adoption of EVs represents a crucial step in addressing the environmental challenges associated with road transportation. On the right shows a pie chart where around 73% of the CO2 emission is by the transportation sector, and 60% of that is by the road transportation alone, which highlights the importance of EVs and the role they are about to play in avoiding the climate crisis. There are several challenges in the adoptions of EVs. Number one being range anxiety, that is not knowing how much to charge for a given journey. High initial cost, that is the EVs having a higher initial cost than the counterpart, that is the combustion engine based vehicles. Insufficient charging infrastructure in many places, battery technology constraints, and the fear of overloading the power grid due to the charging of electric vehicles, and inadequate mineral supplies such as semiconductors. So one of the solutions that we are going to be exploring today is going to be of the EV charge station count prediction. Many times we do not know how many charging slots for an EVCS do we actually require. So using the data from the existing EVCS, that is we can use the existing data to basically train a machine learning model. In our case, we have trained the Serimax model to output the actual useful or the correct number of active charging slots that can help us save infrastructure development cost in the EVCS. Another solution that we are explored is the EV charge station load prediction. That is to know how much that is to have a good idea of how much energy is to be provided to a EVCS, which can later help in planning a better infrastructure for EVCS grid. So the architecture goes as follows. We input the data from EVCS, and then we pass this data into a meta fusion regression model, which is, as the name suggests, is a fusion model of various traditional and very impressive machine learning based models, such as random forest, XGBoost, and decision trees. And later we use this model to output the load prediction of a EVCS. The next frontier, that is innovative solution that we have explored, is that of a route planning for EV. So the objective is designing a route planning system that is tailored for electric vehicles to optimize energy consumption while considering battery stress. Distinguishing features: unlike conventional routing systems, this approach prioritizes energy efficiency over the shortest distance or fastest path. So it involves a physical model and a network representation. The physical model developed is of a comprehensive energy consumption model. A network representation is modeled using the street network nodes and weighted edges, enabling the application of a modified Yen algorithm for finding the energy optimal route. The figure on the right shows that we have three options, each giving cost efficient, time efficient, and an energy efficient route. We'd like to thank the references, that is the research articles as mentioned here, for providing the information. And this is our conclusion of the presentation. Thank you.